Or if it is niche. So if it is a Hello everyone, today we are going to see the project name called the Robust Multi-Sensor Object Tracking System. So this project is about detecting objects and finding the distance accurately using two sensors like a camera and radar. So camera YOLO V8 objects like cars or people, but it can't measure distance properly. So radar can measure distance, but it cannot identify objects clearly. So we combine both using sensor fusion, a machine learning model, random forest. It's with data is reliable and an EKF filter smooths the output. So this makes the system more accurate and stable, useful in applications like a self-driving cars and robotics. So we'll see the block diagram. So this is our block diagram. First we are taking the input data. So with the input we are doing the two things like in the images. YOLO V8 model will detect the objects and it will provide the bounding box along with the confidence book. In the another hand, it will take the lidar depth points and it will do the calibration. After that, it will provide the lidar points on the images. Once after lidar points getting, after it will be pre-processed, like it will be extract the features, depth, noise, those things. After that, it will be given to our ML model. So our ML model will check whether it is a reliable or not. If it is a reliable means, then it will take that object for a prediction. Integrate the sensor fusion here. After that, we'll use the EKF. EKF means extended Kalman filter for a smooth tracking of the objects. So at last it will be visualized in our custom Tinketer GUI. So this is our ML training code. First we are importing all the necessary libraries. After that we are loading our dataset. Actually we have a two dataset. So this is our ML dataset. So in the ML dataset the columns are confidence, depth, noise, and the label. So these are all our ML dataset. So here you can see first we are loading our dataset. After loading, we are cleaning our dataset. If anything like invalid values or missing values or null values there means those things will be removed from our dataset. So here we are setting the features and targets. So as a features, we are taking the confidence, depth, and the noise. So based on this, we are predicting the label. So in the label, ones and zeros are there. So one means reliable and zero means unreliable. It is a one means only it will take that object for a prediction purpose. So this is the training space. So here 20% will goes for a testing and 80% will goes for a training purpose. So here you can see the random forest classifier. So we had used a random forest model to train our data set. Once after training, we got the evaluation. We got the accuracy of our model. So here you can see our model get the 99% accuracy. At last, we'll save the model in the name of ml_model.pkl5. So here you can see, so this is our model. We also have another data set. So this is the data set. So in this data set, it contains the calibration file and the images like as a frames and then lidar points. So these are all our lidar points according to those images. So this is our app.py. So first we are importing all the necessary libraries and then we are loading the YOLO V8 for object detection. After that we are loading our ML model for a reliability checking. So this is our extended Kalman filtering. So this is for a tracking object in a smooth way. This is our database. So we are creating a SQLite database. So database name is users.db. Here you can see users.db. So in the database, it contains our name, email, phone, password. So once if you register means, then it will ask the name, email, and phone password values. Once if you provide means, those values will be stored in our database. When you try to log in means on that time, it will go and select if the user is registered or not. If it is registered means it will allow us for a prediction or else it will throw invalid email or password. Without login, we can't predict the lidar points. So this is our calibration file. So without the calibrations file, we can't get the depth of the images. So we will point out the lidar points to our 2D images. So this is for a projection. So here we will map the lidar points onto the images. So this is for a YOLO distance. So here we are using a YOLO for detecting objects along with the bounding box with the confidence score. So these are all for colors. So if the object is less than or equal to 8 meters means checked along with the distance, it will be displayed as a red color. If it is a less than or 15 meter means then the object and along with the screen will be displayed as a yellow color, or else it will be displayed as a green color. So this is our main process. So first we are taking the lidar points. So based on the lidar points, we are mapping with our images. If anything like any background lidar points or background is there, means those things will be pre-processed. Once after pre-process, those depth will be mapped into our images. So after along with that, YOLO will be used to detect the objects with the names and along with the confidence score. So we use the EKF for a smooth tracking of the objects. So to run the code, we need to type Python space app.py. So it will open the GUI. So this is our GUI. Here you can see the register new account and login. So first we need to register with your details. So if you try to log in means we need to provide the same email address and password which we added for the registration. So here you can see start detection. We need to upload the data set. So this is our data set folder. We have 5 videos. Each videos as images only we have. So we'll upload on data set and check. So here you can see it's processing the images. Once it is completed means here it will be displayed. So here you can see. So if the object is so far means on that time it will be displayed in the green color. If it is near means on that time the both bounding box and also the screen will be displayed in the red color. If it's a medium phase like a medium meters means on that time it will be displayed the bounding box along with the screen as a yellow color. So here you can see the person it is detecting along with the confidence of 71% and the meter distance is 6.7 meter. So if it is a less than 8 meters means then it will be detect the object as a red color bounding box. So here you can see this car is detected with a confidence of 71%. So the meter is level 0.2. So we'll check with the another data set. This is the another data set. So here you can see the colors changing. So if it is a far means it is displaying a green color. If it is near means it's displaying as a yellow color. Based on the meter only it is providing those colors things. Then here you can see the car and the confidence along with the meter. So here we have a back to home button. Thank you.